Good morning, everyone. Welcome to Software Engineering. I'm Zhang Shuang from Software College, Northeastern University. In this lecture, we are going to learn object-oriented analysis, use case modeling. Object-oriented analysis is the next phase after requirements phase. So now let's suppose the requirements has been achieved. And then the analysts are supposed to do 3 jobs for object-oriented analysis. Let's say call it OA. Step 1, use case modeling, is to determine how the various results are computed by the product without regarding to sequencing. And it is largely action-oriented. The product of use case modeling is use case diagram. And step 2, class modeling, is also called object modeling, is to determine the classes and their attributes. It's purely data-oriented. And the product of class modeling is preliminary class diagram. Step 3, dynamic modeling, is to determine the actions performed by or to each class. It's purely action-oriented. The product of dynamic modeling is state diagram. Let's learn use case modeling first. Use case modeling. So what is a use case model? A use case model is a model that describes a system's functional requirements in terms of use cases. Okay, so let's discuss about use case modeling from the following point of view. First, system's environment. It is called actors here. And the system's intended functions, it is called use cases. Okay. And the relationship between or among actors and the use cases. And then we'll discuss the benefits of use case model and also some cases. First, let's discuss actors. When we talk about the use case modeling, the first concept that should be determined is the actors of the target software system. So what is an actor? An actor represents a coherent set of rules that one plays when interacting with these use cases. So that means actors are not part of the system. It is external. And the actors can represent a human, a machine, or another system that plays with the system. So that means actors are not certain to be a human being. It can be anything outside the target system which will interact with the system in some way. Actors can be a giver of information or a passive recipient of information. So that means the actors may give some information to the target system, or on the other hand, the information will give some message to the actors. In the use case diagram, actor is represented as a statement named by singular domain-related noun, which can reflect the role that one plays or adopts in the module precisely. For example, customer. Customer is an actor in an e-shopping system. So when you try to place some order, let's say on Taobao system, and then you are the customer. You are the actors of the system, right? And the student. Let's say the system is a student management system, and your students are supposed to be the users of the target system. So surely your student will interact with the system with some functionalities. So your student is an actor of the target system. Well, next, okay, payment processor. We can see that both customer and the student are human beings. That's okay, but it's also okay for a payment processor to become an actor of the target system. And here, it is indicated as a system. It is an existing system. And this existing system, payment processor, will interact with our target system in some way. So this payment processor also becomes an actor. Timer. Sometimes some system will need timer. Maybe the most famous timer is the timer for our clock. Let's say you will have class at 8 o'clock in the morning, and then you think you'd better get up at 6:30, and then you set your timer of your clock to 6:30, right? And then the timer will send message to the clock to work when 6:30. This condition is satisfied. Okay, so this is timer. So timer can also become an actor. Well, sensor. Sensor is some kind of equipment, right? Some kind of hardware equipment. But for a robot system, the sensor is supposed to interact with the outside, and the sender will send data or message back to the robot system. So in this way, the sensor will become an actor for the robot system. So whatever it is, as long as this actor will interact or communication with the target system, it should be the actor for the target system. Maybe you will ask, we have understood that actors are not part of our target system. Why do we pay attention to actors? We must understand that actors help delimit the system and give a clearer picture of what it is supposed to do, what the target system is supposed to do. And the use cases, that means the functions, are developed on the basis of the actor's needs, ensuring that the system turns out to be what the users expected. So that means the reason that we pay greater attention to actors first for use case modeling is because actors help us to have a look at the target system from different point of view. So in this way, it will be much easier for the analyst to determine what the target software system is supposed to provide for the actors. That means for the future users. So once the actors are determined for the target system, the next task is to determine the use cases of the target system. So a use case is defined in this way, actually. A use case describes a sequence of actions a system performs that yields an observable result of value to a particular actor. A use case describes what a system does, but it does not specify how it does it. So that means use case diagram only answers the question of what, okay, rather than how. So that's why we call it OOA, Object-Oriented Analysis. Discuss in detail about the actions, okay, the actions that will be done by the use case. An action is a computational or algorithmic procedure. It is invoked either when the actor provides a signal to the system or when the system receives a time event. An action may imply signal transmission to either the invoking actor or other actors. An action is atomic. That is, it is performed either entirely or not at all. Okay? So that means use case cannot be split anymore. A system performed, that means the target system will provide the use case. So that means the implementation of the fulfillment of the use case will just take place within the system. And you can put a value on successfully performed use case. A use case should ensure that an actor can perform a task that has an identifiable value. So that means this use case will yield some kind of result. We can't imagine a use case with no result, right? No point. And finally, a particular actor. That means the actor is the key to finding the correct use case, because the actor helps to avoid use cases that are too large. So that means the use case must serve for some particular actor. We can't imagine a use case to yield some kind of result to nobody. So this use case will be pointless, right? Useless. So we can see that use case is supposed to serve for some actors. This is a list of some examples of use cases, such as take course, take exam, deposit funds, place order, book ticket, borrow book, and so on. Surely these use cases are from different software systems. Well, use case symbol. A use case is represented as ellipse with case name inside, which is domain related and starts with strong verb. For example, log in. Some actor will log in, right? So that means some actor will interact with this use case login. Let's say the customer of a bank system will deposit funds. So deposit funds is a use case. A customer of some e-shopping system will place order. So place order is a use case. And let's say in our university, all students are supposed to take course. So take course is a use case. Well, next, the relationship between or among actors and use cases. A use case is initialized by an actor to invoke a certain functionality in the system. And a use case describes the action the system takes to deliver something of value to the actor. A use case models a dialogue between one or more actors and the system. We find that a use case is certain to interact with the actors, to communicate a dialogue with actors. Well, so in our use case diagram, it is certain to determine the relationship between use cases and actors, right? So an actor is connected to one or more use cases by an association, which is represented as a line between the actor and the use cases. Association between the actor and the use case indicates that the actor and the use case communicate with one another, each one able to send and receive messages. For example, customer. A customer of an e-shopping system. And place order is a use case provided by the e-shopping system. And the customer may place order. So the relationship is just indicated as a line between customer and the place order. What are the benefits of a use case model? Actually, a use case model is useful for both the customer and the software organization. The customer approves the use case model. When you have that approved, you know the system is what the customer wants. And then you can also use the model to discuss the system with the customer during the development. And it serves as a contract between the customer and the developers. Next, all the participants of the software organization. That means all the person use it to better understand the system. First, designers. Designer will use it as a basis for their work and to get a system overview. And the next, testers. Testers use it to plan testing activity as early as possible. So use case diagram is a good material for testers, for SQL persons to achieve testing plan, and the developers of the next version. That means those developing the next version of the system use it to understand how the existing version works. Documentation writers review the use cases as a basic for writing the system's use guides. And the architect. The architect checks the use case model to identify architecturally significant functionality. And manager of the software organization uses it to plan the follow-up on the use case modeling and also the subsequent design. So these are the benefits of use case model. We can see that almost everyone who's engaged in this software system will use the use case model. I mean, both the customer and all kind of persons in the software organization. Next, let's take some example of use case modeling. Case 1, elevator problem. I would like to take this example, this case, as the first example for use case modeling, always. Because almost everyone has taken elevator system. It is quite easy to explain this business requirements. Some elevator user will interact with the elevator system to help the elevator system to provide the service for him. Well, actually, we find that it is very easy to interact with an elevator system. And the elevator user, just press some buttons. Press an elevator button or press a floor button. Elevator button means the button inside the elevator. And the floor button means the button on each floor. Although elevator system is quite complex, the use case diagram is really very simple. Case 2, a bank customer service system. All of us are customers of some banks, and what the bank system provides us, well, quite some functionalities, such as open account and also close account, deposit funds, and withdraw funds, and so on. Okay, so this is what we interact with the bank system. So case 2 is also a simple one. Case 3, an online shop or e-shopping system. We are customers. Actually, nowadays, many people prefer to buy something from the online shops because it's quite convenient and most of the time it's quite cheap. So what we have done on the system, surely the customer can browse products on the system, right? And then the customer can also place order on the system. So from this diagram, everyone will understand that the customer will interact with the online shop system in this way. The customer will want to browse products, and the system should also allow the customer to place orders. This is for case 3, online shop. It's also quite easy. Case 4, course registration system in a university. All of you are students, and from this diagram you can see that this is really something that you have done before. So let's read it together. This diagram is quite more complex than the previous ones. So how would you read this diagram? From previous lecture, we have understand that students, such kind of statements are the actors of the target system. So we should find out the statements or the actors first. So from this diagram, we find that there are 5 actors totally: student, teacher, register. And we find that these 3 actors are human beings. Students are just you, and the teacher, it may be me, okay? And the register, it can be some other staff in charge of teaching issues. The 2 other actors are indicated as a system, and we should understand that this indicates that they are some other existing systems. This is course catalog, and this building system. From the point of view of student, we find that the student will interact with the target system. First, view report card. So that means to get his own report or his own scores or grade. And the student should also register for some courses, and the student are required to log in. Only after he has logged in successfully can he view his own grade report or register for courses. From the point of view of teacher, the teacher should also log in first too, and once the teacher is logged in, he can select the courses to teach. So then, let's say, I will select course software engineering for myself because I'm supposed to be in charge of this course, right? And I will also submit your grades to the system. Once I submit the grades, you will get your grade report. Well, these two cases, register for courses and select the courses to teach, also interact with another actor, course catalog. What does it mean? It means that the fulfillment of these two use cases needs the interaction of the system course catalog. Surely the information about the courses will be needed for register or for selecting courses to teach, right? Okay. And the information about the courses can be get from the existing system course catalog. So since this system is there already, we can just use it. There will be some kind of dialogue or interaction between actor course catalog and the use case register for courses and select courses to teach. Well, register. Register is the staff in charge of teaching issues. The first thing he should do before he interacts with the target system is to log in. And once he has logged in successfully, he can maintain the teacher information, maintain student information, and close registration. So that means if the deadline arrives or time's off, time's out, and so on, the registrar can close the registration. Well, for this use case, close registration, we find that it also interacts with another actor, another existing system, building system. So let's say the students are supposed to pay for their registration of courses. So that means once this registration is closed or is confirmed, students are supposed to be charged. The charging will take place in the existing system, building system. So surely there is some kind of relationship between the building system and the closing registration. So we find that although this diagram has quite a few words, we can really get quite a lot of information from it. So that means use case is very meaningful, right? Very useful. Okay. So that's why we say that use case modeling is used by almost everyone who's involved in this project, right? Okay. So just now we have went through several use case diagrams, and we find that use case diagrams are very meaningful. Okay? We can really get quite a lot of information from the use case diagrams. But we must admit that the details cannot be given out by use case diagrams. Okay, so how to indicate the details of the business requirements for each use case? Well, the solution is use case specifications. So that means for each use case, a use case specification should be described for it. So let's see what should be included in use case specification. It should include use case name, brief description, flow of events, relationships, if there's any, and the special requirements, preconditions, or post-conditions, and so on. Okay. Well, okay, so let's take an example. Borrow book in library management system. So the use case name is borrow book, and there are some preconditions for the use case. Library must log in the system before the use case. And post conditions. If the use case is successful, borrowing records must be created and stored in the system. The book state should be changed to borrowed. If necessary, delete the reserving records. Otherwise, the state of the system is not changed. Let's go on. Flow of events. When the borrower wants to borrow physical books from the library, the use case starts. Okay, next, basic flow of the use case. Step 1. Librarian scans the borrower's card number. The borrower is checked whether he is valid or not. Step 3. Librarian scans the book's number, and the book is checked whether the book is available or not. Let's say, if the book is reserved by someone else, this borrower cannot borrow the book. Okay. Step 5. Create a borrowing record. And step 6. Modify the book state to borrowed. Okay, so this is the basic flow. Well, there are two alternative flows. First, the book is reserved by others. Message is displayed, and the use case is over. Second, the borrower is invalid. Message is displayed, and the use case is over. Okay, so this is the example of the use case specification for borrowing book. Okay, so this is use case specification. So you understand that once you achieve your use case diagrams for your project, and then you should achieve use case specification for each use case to let the reader to understand the use case completely. Okay, next. Let's discuss about the relationship between actors. So far, we have understand that the actors are something external to the target system. That means maybe some persons or maybe some machine or some existing software system which will interact with the target system. And the actors will interact with some use cases within the target software system. Okay, so surely there are some relationships between actors and use cases, but that's not enough. Sometimes some relationship will exist among actors. Okay, let's look at this example. You see, there are two actors in this diagram, undergraduate and senior. We understand that the undergraduate will take course and take exam. And what's more, for the senior should also take course and take exam, and the senior is also supposed to do graduation project. But the students of other grade don't need to do graduation project. It's only the use case unique for senior. That means for the grade 4 students. So you'll find that this hollow triangle is used to indicate the relationship between these two actors. Actually, undergraduate is called super actor, and the senior is called sub actor in this case. Okay. So their relationship is called generalization. It's quite similar with the inheritance between classes. Sub actor inherits super actor's actions. So that means senior will also take course and take exam, but the lines between senior and take course, take exam is not necessary, because senior has inherited the relationship between the use cases from undergraduate. And the sub-actor can also have its own actions. Let's say, senior will do graduation project, but the other undergraduates, that means students from other grades, don't need to do graduation project. Okay, so this type of relation is generalization. Okay, generalization. Okay, let's take a look at this diagram. We find that there are two actors in this diagram, clerk and the customer. The customer of the bank system may want to deposit funds or withdraw funds or transfer funds. But actually, it is not the customer who will interact with the bank system. It is the alert who will interact or communicate with the bank system to deposit or to withdraw or transfer and so on. But surely the clerk do all such kind of things for some customers. So that means clerk is the agent and the customer is the requester. So that means customer asks for agency from clerk. And this relationship is called agency. Agency is indicated by dotted line with an arrow pointed to the agent. So dotted line derives from agent requester to agent. Well, in some other systems, there's also such kind of relationship between actors. For example, borrower. The borrower may ask agency from the library to borrow book or return book and so on, right? Okay, so this is agency. Next, let's discuss the relationship between use cases. Still the bank system. Let's say transfer fund. Transfer fund means to transfer fund from one account to another account. But sometimes the source account and the target account may be in the same bank, but sometimes they are in different banks. So actually, there are two more use cases for these two kind of situations. Transfer fund between banks. That means these two accounts are in different banks. And the transfer fund within a bank. That means the source account and the target account are in the same bank system. Well, but basically, both of these two use cases are kind of transfer fund. So this kind of relationship among these three use cases are generalization. So that means transfer fund is the base use case, and transfer fund between banks and transfer fund within a bank are derived use cases. So we use hollow diamond pointing to the base use case. It's really quite similar to the inheritance between classes. Okay, so this generalization between use cases. Next, inclusion. In this diagram, student can query grade. But if the student wants to query his own grade, he must log in. Only after he succeeds in login, and then he can query his own grade. So that means the success of query grade includes the success of login. But for this use case, query class schedule, no login is necessary. So query grade includes login. So the relationship between these two use cases is inclusion. Next, extension. Undergraduate should take exam. And maybe some undergraduates have to make up exam. But make up exam must not surely happen, because its happening depends on the results of take exam. If the result of take exam is fail, and then make up exam will happen. So fail is called the extension point. So at this point, use case make up exam extends take exam. So you see, the arrow is pointed from make up exam to take exam. So extension use case must not surely happen if the result of base use case satisfies a certain condition called extension point. Extension use case happen and base use case extended. So This kind of relationship is extension, and the keyword extend is used to indicate the relationship. And dotted line is pointed from extension use case to base use case. Okay, next concept, scenarios. A scenario is an instance of a use case. It's one flow through a use case. And scenarios make excellent test cases. Let's take the example of elevator problem. So here, this is a normal scenario. Let's read it together. Okay. Step 1. User A pressed the up floor button at floor 3 to request an elevator. User A wishes to go to floor 7. The upper floor button is turned on. An elevator arrives at floor 3. It contains user B, who has entered the elevator at floor 1 and pressed the elevator button floor 9. The up floor button is turned off, and then the elevator doors open, and the timer starts. User A enters the elevator. 7. User A presses the elevator button for floor 7, and the elevator button for floor 7 is turned on. Elevator doors close after a timeout, and elevator travels to floor 7. Elevator button for floor 7 is turned off, and the elevator door open to allow user A to exit from the elevator. The timer starts, and the user A exits from the elevator. The elevator doors close after a timeout, and then finally, the elevator proceeds to floor 9 with user B. Surely this is one scenario for use case for elevator problem. And surely we can get some other scenarios for it. Let's see. User A presses the up floor button at floor 3 to request an elevator, and user A wishes to go to floor 1. The up floor button is turned on. An elevator arrives at floor 3. It contains user B, who has entered the elevator at floor 1 and pressed the elevator button for floor 9. The up floor button is turned off. The elevator doors open. The timer starts. User A enters the elevator. User A presses the elevator button for floor 1, and the elevator button for floor 1 is turned on. The elevator doors close after a timeout, and the elevator travels to floor 9. Elevator button for floor 9 is turned off, and the elevator doors open to allow user B to exit from the elevator. The timer starts. User B exits from the elevator. The elevator doors close after a timeout, and the elevator proceeds to floor 1 with user A. Okay, so these are the scenarios for elevator problem. Surely you can get more scenarios for it. And you can see that this will become good test cases. Okay, finally, your homework. You are supposed to get use case diagram for your own team project. Okay, so much for use case modeling. Thank you.